ALPR using YOLO object detection. ALPR stands for Automatic License Plate Recognition, and YOLO stands for You Only Look Once Object Detection. This proposal made by me, Anthony Jethro Leander, based on my senior proposal paper, Aditya Radia. The first introduction. To do automation in a city by using Automatic License Plate Recognition, or ALPR. ALPR can be used in automatic toll collection, traffic law enforcement, and private space control. This technology will detect license plate and get license number from a vehicle. By using ALPR, hopefully, crime will be decreased because we can detect the plate and we can detect who owned the vehicle. To do that, ALPR need high performance computing to run it in real time. So we will need CNN for the second research background. CNN is a deep learning algorithm that uses machine vision to recognize plate. It could recognize plate in bad lighting or noisy image. So CNN could detect the license plate as long the image still visible. Unlike ALPR that require clear image and certain angle to accurate reading. Okay, determine YOLO. You only look once. Object detection. YOLO use CNN deep learning algorithm, and YOLO performance could detect up to 100 FPS or 100 frame per second or image per second after training it with deep learning. It will possible for low performance computing. So we can do ALPR in low performance computing in real time. Resource problem. YOLO used to detect object, not character in license plate. So it will only detect the license plate. So we need to train it to detect character in license plate. So it will give us output in number or alphabet. Research scope. This research will be used against CCTV camera in parking space or security post to obtain license plate. Research objective to create license plate recognition in real time that can be used in low computing power. Because if we need high performance computing, it can be done in massive amount to detect license plate. Research advantage. Research advantage. This research will extend the capability of YOLO to detect object. So it now can detect character from license plate. Literature review. The first for new CNN, there is paper from Krzyzewski, Zutskiver, and Geoffrey in 2012. The next is RCNN or region-based CNN object detection from Gristic 2014. And there are also high-speed detection from Redmond in 2015. Basic theory. I don't really understand about this theory because I haven't studied about artificial neural network. The next is activation function, stochastic gradient descent, and convolutional neural network. And the last is YOLO object detection. YOLO will use CNN algorithm that work by input an image and use CNN to detect multiple objects from an image that's fast enough for real-time object detection. This system will split image into grid that can have multiple boundaries. Each block will detect object depend on the number of boundary allowed for the grid. To add more grid, more computational power is required to detect an object. The YOLO object detector is able to detect multiple objects within the image in one feed forward on the CNN, since the result of CNN or output layer will give matrix of 5 prediction. There are numerous types of YOLO available, such as YOLO, YOLO version 2, YOLO version 3. but the most commonly used are the tiny YOLO and the YOLO original architecture. The major difference between the type of YOLO is the number of layers used in architecture. This difference in layer will result in different capabilities such as computation time, MAP, and the number object will be detected accurately. For the research methodology, the data will come from UGM CCTV from the parking lot to detect license plate and license number. Experimental. It will train CNN to detect license plate and license number from dataset of parking lot CCTV. It will train each architecture with different amount of dataset to measure the efficiency of each architecture. Implementation. It will use a PC to run implementation. It will use a PC to run the code and input the data and have result. It also have some library from Python. Research schedule. There will be literature study, analysis, data acquisition, CNN model design, experiment and implementation, evaluation, and thesis report.